Then we need to share sound. Okay, we have 5 more questions to review. So I'm going to put question 11 from the test. Question 11 is a problem like this. I have 2 to the power of x squared minus 2x is equal to 8 to the power of 2x minus 5. This equation is given, and they say S be the sum of the solutions. Let S be the sum of the solutions. What is S? This is question 11 on the test. So this is lesson 4.5. We have an exponential equation is given. 2 to the power of x squared minus 2x is equal to 8 to the power of 2x minus 5. We're going to solve this equation for x. Okay, what do you think I should be doing first? What am I going to do? We're going to try to write them with common basis. Is it possible? What's the base on the first part? 2. Can we change this to a 2? Can 8 be written as a power of 2? 8 is 2 to the what power? 3. 8 is 2 to the third power. So the first part will be copied the same. So 2 to the power of x squared minus 2x is going to stay the same. But we're going to change the 8 as 2 to the third power because this is still an 8. If you multiply the 2 3 times by itself, you just get an 8. And 8 is raised to the power of 2x minus 5. Okay, so this is what we have so far. The first part, we're going to copy it one more time. 2 to the power of x squared minus 2x equals to 2 to the power of, now 3 times 2x is 6x, 3 times 5 is 15. Now I got them in common basis. If this is an equation, if they're equal to each other, if the bases are equal, we just have to set the powers to equal to each other. This is what we need to set up and what we need to solve for x. X squared minus 2x must be equal to 6x minus 15. As I told you before, we're going to change this to a quadratic equation by moving everything to the first side and setting equation to a 0. If I organize this, this is what I got as a quadratic equation. Okay, can you guys guess the factors? What will be the factors here that I need? How can I factor x squared minus 8x plus 15? Good job. X minus 5 and x minus 3. Because when we multiply these two negative numbers, it'll be a positive 15. When I add them up, it'll be a negative 8. Did I solve it? I only factored it, right? So this one gives me x equals what? 5. And this one gives me x equals what? 3. So I got two solutions here. Okay. So if S is the sum of these two numbers, what am I going to do? 5 plus 3 is 8. I still want to check if any of these won't work with the original problem. 5 squared, 2 times 5, 25 minus 10, that's 15. This should be just 5. 2 times 5 minus 5, that works. If you try 3, 3 squared is 9, 2 times 3 is 6, 9 minus 6 is 3, and this should be just 1, and it works. Yes, both of them are accepted, and this will be this answer. Questions for 11. Now we're going to write down question 12 from the test. It's find the inverse of f of x is equal to 5 over 6x minus 32. We're going to find the inverse of 5 over 6x minus 32. This is our number 1. We did this question on number 1 too, right? So we're just going to repeat the process again. Do we drop the f of x? Do I drop the f of x? Instead of f of x, what am I supposed to write? F of x will be dropped, and instead of f of x, I'm going to write y. So we're going to rewrite the problem as y is equal to 5 over 6x minus 32. That's step number 1. The most crucial step is replacing the x and y, right? So we're going to rewrite this equation as x is equal to what? 5 over 6, y minus 32. Good job. This is the most crucial step. Replacing the x and y is very important step for finding the inverse. Now, all we're going to do is solve this equation for y. If you like, you can multiply everything by 6 first to get rid of the fraction, right? If you just multiply everything by 6, this is just a 6x. And then here the top 6 and the bottom 6 cancels out, and you just get 5y. And 32 times 6 is 192. Rest of it is just a basic algebra solving for y. So I'm going to add 192. 6x plus 192 is 5y. Finally, we're just going to divide each side by 5. So the expected answer is f to the power of negative 1x, because instead of calling this a y, we're just going to call it inverse function. The answer will be 6 over 5x plus 190 over 5. This is what I'm going to give them as an answer when they ask me this question on the test. This is the answer for question 12. Anybody has any questions? We have 3 problems left. Question 13. I have to think about this for a while. This is going to work. I want to put a 1 here, and then I want to put log base 9, and then I'm just going to erase my work here. I hope that the numbers I just made up in the air works for the problem. So question 13 is an example from 4.5. It's about logarithmic equations. It says log base 9 of x minus 5 plus log base 9 of x plus 3 is equal to 1. And the question says let S be the sum of the solutions. If there's only one solution, S will be equal to that only one solution. Find S. So basically, in this problem, we're going to solve this log equation, and then we're going to add our solutions. If there's only one solution, we're just going to add one number, or we're just going to keep it as is. Okay? So, solution. We're going to start applying properties of logarithms. I have two logarithmic expression here. Do they have the same base? Yes. And their connection is a plus. If their connection sign is a plus, what rule can I apply here? If you are using a plus for two different logs, what can you do here? Yes, you can use the product rule. So instead of having two different logs, you can just have one log space 9. So you can just connect them together. And when you're connecting, plus means we're going to multiply x minus 5 and x plus 3. So these two numbers will be multiplied because of the product rule. And then this is still equal to a 1. Okay. So this is how we organize the problem so far. I'm going to keep organizing it, log base 9. And then we're going to distribute x minus 5 and x plus 3 here. X times x is x squared. X times 3 is 3x, but then I will have a negative 5x here, which will make a total of negative 2x. And then negative 5 plus 3 is negative 15. And this is still equal to 1. So I have this log equation that I need to know how to convert to an exponential equation, and I need to solve this. We talked about this, saying that all log equations can be converted to an exponential equation, right? What is the base here? Base is 9. We're going to keep the base as 9. But 9 will be raised to the what power? 1. And this will be equal to the what? X squared minus 2x minus 15. This is how a log equation can be converted to an exponential equation. 9 to the first power is always equal to x squared minus 2x minus 15. And 9 to the first power is just a 9. We're going to subtract 9 on both sides to set up our quadratic equation. So I got x squared minus 2x, negative 15 and negative 9. When I combine them, that makes total of negative 24, and that's equal to 0. So I just got a quadratic equation that I need to factor to solve this log equation. Okay, so what two factors I need here? Good job. I need the x minus 6 and I need the x plus 4, because negative 6 and positive 4, when you multiply them, it's a negative 24. When you add them up, it's a negative 2. Now we need to solve each one for x. This one gives me x equals what? 6. This one gives me x equals what? Negative 4. Now I need to check if I'm accepting both of them or if I'm rejecting any of these. 6 and negative 4. So this is how I check. So we take the 6. We go to the very original problem. 6 minus 5. Is it a negative number? No. So there is no problem here. 6 plus 3. Is it a negative number? No. So 6 doesn't create any problem. 6 will be accepted because it doesn't create any negative number after the log function. Now we're going to check negative 4. What's negative 4 minus 5? Negative 9. So this will be rejected. So I don't even have to check further. Just because it creates a problem, at least one log function, this will be rejected. So there's one only answer here. So S will be just the one number. So here, the expected answer on the test will be S equals 6 if a similar question like this shows up, right? This is how we solve the log equations by converting them to an exponential equation. Okay, I was multiplying x minus 5 by x plus 3, right? X times x is x squared. X times 3 is a positive 3x. But then you also multiply negative 5 by x, which is a negative 5x. And then you combine the 3 and negative 5x, that gives you a negative 2x. Okay, question 14 is a fun one from the test. And this is something you have seen before. So it's just going to be a repeat. So we're going to write this as a sum or difference of logarithms. So log base 5, parentheses, the top is x to the 7th power times 5th root of a, and the bottom is just b. So we're going to write this as, write this expression as the sum or difference of logarithms. Okay, there's another question just like this, and we did this in the other class, right? So let's start solving this problem together. What's the first thing I should be doing? We're going to apply the properties of logarithms here, right? How many properties are there we need to know? 3 properties. We have the power rule, we have the product rule, we have the quotient rule. Which one is so visible here? Which property of logarithms are so visible here? We have the quotient first. So we will have log base 5, and then the top one is x to the 7th and 5th root of a. Quotient rule means what sign do I need to use when I'm separating them? Minus, and then the other one is log base 5 and b. So we just did quotient rule. If we are dividing two things, we can separate them by using a minus. That's the quotient rule is. Inside the first parentheses, what rule do you guys see now? They are getting multiplied. So what rule we can apply? Product rule. So the product rule means we can separate this part as log base 5, and the first number is x to the 7th. Now we're going to use a plus because we're multiplying these two numbers. And the second one we need is log base 5 and 5th root of a. And then the last part will be just copied because there is nothing happening on the last part. One last thing we have to apply is the power rule, right? What's a power rule? Whenever a logarithmic function gets a power, where does the power travel to? To the front, right? This is easy, but we have to rewrite the 5th root of a to apply the power rule. So instead of 5th root of a, I have to do a magic here. 5th root of a is the same thing as what? A to the power of 1 over 5. All radicals can be expressed as a fractional power. Now, 7 goes to the front. So this becomes 7 times log base 5 of x. 1 over 5 goes to the front. So I'll get 1 over 5 times log base 5 of a. And then the last one doesn't have any power. So we're just going to copy it without a power. And this will be the answer you will pick on the test for a question like this. All right, that's our number 14, which was from 4.4. Number 14 is from 4.4. We have one last question left to study for the test. Then you guys will be ready for taking the test on Wednesday. So the last question is from 5.4. I'm going to go here. Question 15 on the test is, solve the nonlinear system. Solve the non-linear system. And then at the bottom, let's say we have 4x squared minus y squared is equal to a number. And then we'll have negative 2x plus 1 is equal to a 3. If I keep that like this, that is not going to work. So I have to change this to a 5. I'm just going to change this to a 5 because think these numbers should work according to my calculations. Let's see. I hope everything is going to go smoothly. But I do remember that you had this question in your Alex homework, so you can just go to your 5.4 homework and then you can put nicer questions, nicer numbers. Okay. So question is, negative 2x plus y is equal to 3, and 5x squared minus y squared is equal to 4. We're going to solve this nonlinear system, and S is the sum of the y coordinates of the solution, so we're going to find the S. So S is sum of the y coordinates of the solutions. Okay. What's the first thing I should be doing? Are we going to use the first equation? Negative 2x plus y equals to 3. How can I manipulate the first equation so that it becomes useful for the bottom equation? I want to manipulate the first equation so it becomes useful for the second equation. Who is alone here? X or y? Y. So we're going to isolate the y. If I isolate the y is equal to, there's a 3 already on the other side. This negative 2x is going to go to the other side as positive 2x. So y is always the same thing as 3 plus 2x. We will use this information. On the other equation, we're going to replace the y with 3 plus 2x. Okay? But when we look at the other equation, in the other equation, we don't have a y. Instead, what do we have? We have a y squared. Let's just calculate the y squared. If y is 3 plus 2x, y squared will be 3 plus 2x to the second power. So we're just going to have to multiply it by itself, which will give me a 9. And then that's 6x, another 6x, total 12x. And then 2x times 2x is 4x squared. This is what I get for y squared when I square this expression, okay? Y squared is the same thing as 9 plus 12x plus 4x squared. And I got this answer when I squared 3 plus 2x by itself. So from the problem, we have this given equation, 5x squared minus y squared is equal to 4. This is given in the problem. So I'm going to copy the 5x squared, but instead of y squared, I'm just going to write down what I figured out. Y squared is the exact same thing as 9 plus 12x plus 4x squared. This is what I got from my own calculations, and this must be equal to 4. So the reason we are trying to change y squared with this, so that the equation can be only in terms of x. So organize it. I'm going to just change everybody's sign with negative because of this negative here. And then I will move the 4 to the other side as negative 4, so I can set up the equation to 0. Then I organize 4x squared minus 5x squared minus 4x squared is just 1x squared. We have the negative 12x, and negative 9 and negative 4 gives me a negative 13 is equal to 0. Here's another quadratic equation that I need to know how to factor. So what factors do I need here? Good job. I need x minus 13 and I need x plus 1, because if you multiply negative 13 and positive 1, their product is negative 13, and when you add them up, their sum is negative 12. This one gives you x equals 13. This one gives you x equals what? Negative 1. All right. For each of these, what are we supposed to calculate now? For each of these x values, what am I going to calculate? I need to calculate the y coordinates, because the question is asking me to add the y coordinates of these solutions. So if I remember from the top of my question, I know that every time I need the y is always 3 times 2x. I can use this to generate the y outputs. Y is always 3 plus 2x. So I'm going to apply y is equal to 3 plus 2x formula for 13. For 13, I need 3 plus 2 times 13. So 2 times 13 is 26. 26 plus 3 is 29. That's one of the y coordinate I will get. Here, again, the same formula, y is always equal to 3 plus 2x. But this time, I'm going to plug in a negative 1. So 3 times 2 times negative 1. That's equal to a 1. So I got two different y values. So S is because the sum of these two numbers in this problem, the test asking me to find the answer third here, because this will be the sum of these two y solutions here. That's all questions from the test.